All right. Hello, folks, and welcome to another edition of The Binding Status. My name is Dan Mangum. I'm your host every 2 weeks. We typically have folks from different cloud native projects on this show to talk a little bit about the work that they're doing, as well as how it integrates with the project I work on, which is Crossplane. And today we have a very special guest, Nic, who is a steering committee member and maintainer of Crossplane itself. So, we're usually looking at different CNCF projects and exploring their architecture and that sort of thing. But we thought we'd take some time, especially with Crossplane v1.0 coming out shortly before the new year, to actually take a look at the status of Crossplane, right? So we frequently integrate with it and show how, different projects can play nicely with it. But we'd actually like to take a look at the architecture. And a lot of folks, as more folks are starting to use Crossplane, especially with kind of this 1.0 commitment, are discovering sort of the unique aspects of Crossplane that differentiates it from other projects or makes it different from traditional infrastructure management and provisioning. So we really wanted to have Nic on, who's kind of a lead architect of a lot of the things that we've built with Crossplane, to chat about that architecture. And we're going to keep it pretty open-ended. So I know there's already a few people in the chat. I see Rich is joining, Jeremy, Phil. Appreciate all y'all tuning in. We definitely want this to be interactive. So I'm going to ask Nic a lot of questions and kind of take like a user's view of Crossplane. But we'll also periodically circle back to the YouTube chat and let you all ask questions and just kind of go down any path that takes us. But Nic, do you want to kind of give yourself an introduction? I know you've had a lot of different roles at different companies that kind of inform your design decisions these days. So I'd love to hear a little bit more about your background and what you do today with Crossplane.
Sure. So, first, Dan, I'm curious. Why is this live stream called the Binding Status?
So, well, it's not as useful as the name used to be, but a long time ago, and maybe this will actually kind of fit into our conversation down the line. But earlier on in Crossplane, we used to have claims, which we have today as well. And we'd have classes, right? So you'd have like a class of infrastructure, and then a claim, and it was namespace scope to cluster scope. And there was a ability to basically provision a resource and then bind to it later on. And then when those two things become bound, if you may have noticed this if you're familiar with Kubernetes, it's like persistent volumes and persistent volume claims. They'd become bound to each other, and we'd have an actual binding status, right, as it successfully bound to the underlying resource that it wants to use. We don't really have that anymore, but it is kind of like a fun artifact, right? I feel like that now people like name shows or different things after like retro computing things. So in our very short Crossplane history, it's our retro naming. So that's a little history for the show for y'all.
Yeah, sorry, folks. I'm just teasing Dan because the show was named after a feature that we removed from Crossplane. So, hi everyone. I'm Nic. I've been working on Crossplane for about 2 years, a little over 2 years now, actually. So I joined the project just after the 0.1 release. I actually met the founders of the project, Bassam and Jared, on the day of the 0.1 release. I think the day it was open sourced, and like they hadn't slept the night before and things like that. We started chatting about Crossplane. So I got involved shortly after that. So the way that I found my way toward Crossplane as a project is I have been a site reliability engineer for most of my career, for probably about 10 years before I started working here, working at Upbound, the company that sponsors Crossplane, and working full time on Crossplane. That is. So my first job. Because my first job, I was actually a tech support guy at Google. I was a field technician. But then after about a year of doing that, I moved into a SRE team at Google, and was there for about, I think, 5 or 6, maybe 5 years, which was a really nice place to sort of start learning about some more progressive ways to manage infrastructure. This was back in 2008, 2009, thereabouts. So a lot has changed since then, but obviously, companies of that kind of scale, especially Google, do have known for inventing the whole SRE concept and publicizing that. I remember sitting around with some of the folks in the Sydney office, and one of them came back from a local meetup, and they were like, guys, like the larger world has discovered this concept of SRE, and they're calling it DevOps, and it sounds really similar to what we do. Yeah, cool. So there I was working on internal authentication infrastructure primarily, the LDAP, Radius, a bunch of other weird stuff, which is kind of funny because it's the kind of stuff that you would expect to not have that many customers, but the scale of that company, there was something like 10,000 users using our authentication infrastructure. I was on call for Google's Wi-Fi networks internally, which was a fun place to be. Anyway, after I was there for a little while, I was starting to sort of get bored of having worked mostly at one company for my entire career. And I ended up, a recruiter hit me up to go to, try to get me to come move to Sweden to work for Spotify. And I said, hey, I really want to go to Sweden, but I know you've got an office in New York, and I'd love to go there. And that worked out really well for me. I was a SRE again at Spotify. I was around employee number 1,000 of Spotify, which seems like a lot compared to Upbound, where 20 folks or thereabouts. But Spotify held on to the really startup vibes for a really long time, and there's good and bad parts of that. When I joined the SRE team there, they shortly after I joined sort of formed into the infrastructure and operations tribe, and really sort of started moving away from sort of more of an old school systems engineering, sort of just keeping the infrastructure running role, into much more of a like team focused, project focused, mission focused, like set of squads. And my team was given the mission that seemed a little unexciting at first, but then turned out to be super fun, which was basically Spotify was started in 2006, about the same time as EC2, I think, and AWS. So Spotify was using we had 4 data centers around the world. I think by the time I left, we were starting to move to Google Cloud by the time I left, but we had 20,000 or something like that servers in data centers. And when I joined, there was sort of a little Ruby script that would connect to the out-of-band management on a server and boot it up and start a Puppet run to actually set up the server as a particular service. My team basically were told, hey, it's 2013 now or something like that. All of our new engineers have used this shiny new AWS thing, and they find it really weird that they have to raise a ticket and wait for 2 weeks to get 10 servers to run their service on. Can you build them in EC2, please? And that's what my team ended up doing for the time at Spotify for a couple of years. My last year at Spotify, I moved on to a system called Helios, which was Spotify knockoff Java Kubernetes. It's not the fairest way to put it. Spotify announced Helios at the same DockerCon that Kubernetes was announced, and Kubernetes was much better architected and won out deservingly in the end. So I found, Dan, I can talk for probably the full hour monologuing about my career, so I'll try and wrap it up now. One thing I found really interesting and really rewarding moving from Google to Spotify was I found that at Google, you're working on this amazing hyperscale stuff, but often you end up taking on a system that people have, especially in SRE, you end up taking on a system that people have worked for like years before you get there. And so at Spotify, I kind of felt like they handed me this like blunt pencil. They're like, this pencil is blunt. You need to sharpen it. Like, machine provisioning doesn't work very well. We need you to like really automate it end to end. Whereas at Google, it was a little bit more like, people have been sharpening this pencil for 10 years. We need you to like, polish it to a micron slightly sharper sort of thing. So I found sort of the increased impact of going to a smaller company to be really rewarding. So I tried that a couple of times at a few startups around the Seattle area, including Planet Labs, which is really cool, a company that has the world's largest fleet of Earth monitoring satellites. But I increasingly found that at small companies, it makes a lot more sense to use existing open source tools than to really dive deep on building game-changing infrastructure. So I decided to look for companies that were building game-changing infrastructure, found Crossplane, and that's how I ended up where I am today.
Yeah, well, I love the background that you have there, because I feel like A lot of those experience, right, it form the design decisions you make now. And it looks like Jared's also in the chat. So Jared's one of those people that I guess you saw at KubeCon when Crossplane was announced. But as someone who's kind of like somewhat younger in the industry, it often finds myself like a little jealous of these like terrible things you had to do sort of like. So you mentioned developers opening tickets for servers, and getting them 2 weeks later, which Rich commented that is not super fun to have to do, but that's what a lot of people's experience has been, right? Now we kind of just take for granted, right, that you should be able to spin up an instance, and if it takes like 5 minutes for a GKE cluster to come up, we're frustrated. And so I feel like that I in some ways have some shortcomings in the areas of understanding like the pain that we've moved on from, right? So in some ways that's good because I can look at it and say this is how the world should be. Like I would never do it that old way. But in other ways, I'm not able to let those experiences inform me, right? Because I didn't have those same ones. So I think it's really cool to kind of notice those anti-patterns from things you've done earlier on in your career, or experiences you've had, and then apply them to the direction we go moving forward. So I think that's super valuable.
Yeah, and it's important to keep in mind it's easy as you go more and more into the cloud. It happened to me. Like now, I'm so used to the same kind of thing. If my Kubernetes cluster takes more than a few minutes to spin up, I'm frustrated. But at the same time, there's still plenty of folks out there, doing roles like that at companies that still, for whatever reason, are using their own data centers, haven't got that full automation sort of thing. So it's something that's a challenge when you're working on projects like Crossplane. You're at the cutting edge of sort of infrastructure management. You have to remember to think about folks who are still dipping their toes into Kubernetes in the first place, sort of thing, or still sort of beginning a cloud native migration journey.
Yeah, absolutely. And I think that's one of the things maybe we can touch on as we explore the Crossplane's architecture, right? Because most users, the vast majority of demos we've done on TBS, right, are with GCP or AWS or Azure, et cetera. And a lot of them are even not with the kind of like most bare infrastructure they give you, right? So not with VMs essentially. But one of the things that's great about Crossplane, right, is that it kind of meets you where you're at, right? And it kind of has like infinite extensibility, if you will, right? As long as there's an API that you can call out to. Crossplane can work to manage that. You can have common abstractions across, the thing that you're provisioning your data center. You could even have Crossplane open a ticket for you, right? And report on the status of that, all the way up to, provisioning that GKE cluster. So yeah, I think that's a great point. I did want to jump a little bit into some of the design decisions that have happened with Crossplane, and maybe we can talk a little bit about, the evolution over time. But I know you kind of have sort of like a philosophy about like the whole project, right? So there's granular portions that work together to create this system. But I thought you might want to start off with just saying like, kind of what's the problem we're trying to solve, right? What is the vision of an organization that uses Crossplane to its full effectiveness?
That's a really good question. Something I've been thinking of a way to sort of crisply put together recently. And this is just my personal take, so I don't take this as necessarily the formal stance of the project. But I'm increasingly starting to think of Crossplane as a toolkit that folks like SREs, platform builders, can use to build their own platform, which you could also say build their own control plane, build their own API, to provide to the developers that they support. So, and that doesn't necessarily mean like a standalone control plane or anything like that. That can still be done in the form of an add-on to an existing Kubernetes cluster. But I think what makes Crossplane unique to me is that it's taking this sort of cloud native Kubernetes control plane approach to managing. I say managing infrastructure a lot, but really managing anything. Like one of our co-workers at Upbound, Grant, made the typical Domino's pizza provider for Crossplane. So while it's very often used to manage cloud providers, AWS, Azure, etc. Absolutely doesn't have to be. It's very, very pluggable. But I think one of the key differences Crossplane has is that it's extremely flexible and it lets you pick what your APIs should look like. And this is something that I've really seen and struggled with before in my career, and it was definitely something that sort of informed my thinking about it. You know, going back to my time at Spotify, after we had built Spotify's internal EC2 alike, we started moving to Google Cloud, and there was this really challenging decision that we had to make, which was, you know, do we just give our developers GCP accounts? You know, does everyone just get the keys to the kingdom, and you know, we sort of just have a high level of trust to say that people do the right things, which not that we think that our developers that we were supporting as sort of the SREs and the platform teams there would be malicious or anything, but the surface area of what you can do with the cloud is huge, and there's just, you know, there's entire courses you can take that would probably take you years to learn everything you can do with just one cloud provider. So making sure you make decisions that are secure is challenging, as you know, there's entire jobs that are built around that. Making sure you know, right size things so you're not spending too much money, but at the same time you're having reliable infrastructure. You know, your databases are, you know, replicated, things like that. It's and you know, not to disparage engineers. Many engineers are great at that kind of thing, but equally many don't want to, sort of thing. So we really struggle with that at Spotify. And to be fair, I left shortly after we started the migration, so I think they probably do things pretty differently. I don't want to speak as to how Spotify does stuff, but at the time, one of our thoughts was like, we would like to build our own APIs and our own system on top of Google that looks a lot like the existing dashboards and concepts that Spotify engineers were used to already from the previous system we built, to sort of ease that transition and put some guardrails on things so that, you know, we were letting people choose certain settings as the SRE teams. You know, you could maybe pick how much storage space your database wanted, but then certain other settings, maybe like what machine type it was or how replicated it was, were kind of fixed, and we set those. And that's, you know, something I saw. It was the same kind of thing, even from a multi-cloud standpoint. When I was at Planet Labs, they were moving from AWS to Google, and we had folks, particularly I remember within the machine learning team, who were like, I know Postgres pretty well, and I'm building a system on top of Postgres. I really don't care about how RDS works. I really don't care about how Cloud SQL works, the differences between the two. I would really love you SREs to just tell me what the settings I want for my database are and give me a database and get out of the way, sort of thing. But at the same time, we didn't want to have a whole team of SREs just lovingly handcrafting databases for people. So it needs some automation.
Yeah, absolutely. I feel like there's that can be a tough balance, right? So there's the two sides of it. So it benefits the infrastructure team in that you can be more restrictive in what you provide, right? You can have a better grasp over what kind of things you're making available for self-service. And then from the developer perspective, you don't want to be constrained by those restrictions, right? But you want kind of the right balance of being able to not have to know everything, right? You don't have to take those courses that you were talking about. I remember at a consulting job I had, we had to take these AWS training courses, and they'd take like literally months of study, you know, like every night to understand them, right? And there was no need for a developer to have all of those keys. And so finding that right balance can be kind of difficult. And one of the things I like about Crossplane, right, is it allows you to kind of iterate on that balance and do it as code, right? Or do it as YAML, if you want to call that code, to the point where you could actually take an abstraction, fork it, change one field, right? Or push an update to your repository, and you can slightly shift these abstractions around. And it really doesn't take any knowledge of the underlying resources, right? If you're deciding how things get like piped from the abstraction to the more granular resources, that could obviously require some expertise, right? That an infrastructure team would have. But it does allow for this portability story. It allows for this easy kind of like iteration story, which I think is really valuable in finding that right place between the two teams.
Yeah. The portability part is interesting because I think our original push and messaging around Crossplane did prioritize portability a lot, and portability is important for a lot of people, and it's something that we absolutely enable. But I really feel, to me, you know, again, with my background and my perspective, the power to me really comes from you know, what we often call separation of concern here. You know, this idea that we believe that the typical developer using Kubernetes to deploy their application shouldn't need to deal in low-level infrastructure APIs. They shouldn't need to be effectively understanding the RDS instance create API call and writing one of those out. We should be able to leave that up to the experts, the folks who get passionate about that kind of stuff, the SREs and platform teams, and have them sort of offer their view into those APIs. So architecturally, the way that Crossplane works, and this is interesting because Crossplane is often, a lot of people look at Crossplane as a cloud infrastructure management tool sort of thing. So we'll be compared to things like Google's config connector or Amazon controllers for Kubernetes as your service operator. There's an increasing number of tools out there that are taking this approach of letting you use Kubernetes to manage stuff that's not containers, basically, or particularly to manage to act as a shim to other APIs, cloud provider APIs specifically. I don't know what you would really call those tools. I'm thinking of them as like cloud provider infrastructure add-ons or something like that. But a lot of people come to Crossplane and they're like, oh, Crossplane is one of those. It's a multi-cloud one of those. And I can totally see why people look at us that way, because there are a lot of parallels, but there's also a lot of like subtle differences, and those are really informed by this idea that again, we're a tool for platform teams to build a platform on top of systems like a cloud provider or Domino's Pizza or whatever else you would like to offer to their developers, sort of thing. So the way that Crossplane comes together is, off the top of my head, I'm going to say there's three major parts to Crossplane. The lowest level, there are the providers. Providers are very similar to something like Google's config connector or ACK. So these are a Kubernetes controller that adds a set of generally related custom resources to Kubernetes, installs CRDs to add custom resources to Kubernetes. So you can imagine, we have one for Helm that the custom resources it adds is basically a Helm release that you could use to go deploy a Helm chart. We have one for Rook to go and manage. What does that manage, Dan? You wrote that, I don't remember.
It manages the Rook CRDs, right? So from one cluster, you could create instances of Rook CRDs in another cluster.
Got it. We have a relatively new one that some of our friends from Vision are working on that manages SQL databases, users, grants for Postgres and MySQL. And then, of course, we have one for most of the big clouds. So we have one that adds RDS instances for Amazon or Cloud SQL instances for Google, or just talking about databases because they come to mind first, but Kubernetes clusters, everything else. So to my mind, that's the low layer that's the lowest layer of Crossplane. And back in the day, around back in the 0.1 through 0.3 timeframe of Crossplane, we had some decisions to make about like how those custom resources would look, whether they would be opinionated, whether we would sort of, if you ask for a Kubernetes cluster, maybe we would have the opinion that in fact that means in Google you get a GKE control plane and 3 node pools or something like that, or whether we wanted to go in another direction, which we ended up going with, and which many of the other tools in this space have picked the same thing as, which is what I think of as high fidelity resources. I call these managed resources, and the resources that Crossplane is managing for you at this lowest level. And so these managed resources are really just faithful transcodings of cloud provider APIs to Kubernetes, to the extent that we're staying within API conventions and whatnot. But we really have no opinions about, we don't change any fields or anything like that. If RDS has a data disk size field, we'll have a data disk size field, and we'll try and do everything we can do there. But from the get-go, we're kind of like, this doesn't really feel like it's the most just say it's not fit for human consumption. That's a little harsh. It's not the easiest to understand way to manage things. I mean, it's not that different from just having sort of curl and making API calls to sort of a cloud provider's endpoint. It's in Kubernetes, which is great. So you get tooling consistency. You can manage everything in one place. But if you just have that layer, you start to run into things like to spin up a database, you rarely just need to say, hey, give me one declarative RDS instance. It actually cascades pretty quickly. We have an example on the Crossplane documentation. Dan, can I share my screen?
Yeah, absolutely.
Let me see if I can pull up one of these examples. Let me just to give a bit of an illustration here. So I'll get into a little bit more of the architecture in a second, but we have somewhere in here.
I think in the if you go to the welcome section.
Sorry, right, I always get those two confused. There we go, package infrastructure.
Yep.
Yeah, so we have some examples in here of how you might create a database. And in some cases, just ignore all this sort of Chrome around it and just focus on this RDS instance, so this array of resources. In some cases, you can just say, hey, give me an RDS instance. But that assumes that a whole lot of supporting infrastructure to make that RDS instance reachable from the internet and usable and interesting has been set up externally, using maybe another tool, some kind of infrastructure as code tool like Terraform, or just from bootdooping buttons in the API. If you really want to bring all of that into Kubernetes and like sort of go from zero to a working RDS instance, something that looks a lot more like this. This is creating a VPC, it's creating 3 subnets, it's creating a DB subnet group, it's creating an internet gateway, it's creating a route table, it's creating a security group, and then finally it's creating an RDS instance. And so I don't think this even like touches on the IAM stuff that you might need to as well to get this going. And this is like, I would argue that most developers who just want to deploy an app and have a database with it, and this is not a production ready replicated, this is just a sort of a toy one. I would argue that most developers don't want to be writing that much YAML just to get a database. So Crossplane has those, but they're again not intended to just sort of give to developers to go and spin up and work with. So on top of that, we have some tools that make it easy to build your own APIs. Firstly, we have the package manager. Package manager basically just lets you declaratively add and remove those providers. So you can say, hey, I Crossplane, please extend yourself with support for Google, let's say, or support for SQL databases. And then we have a part of Crossplane that we think of as composition, is the general name of the feature or functionality. And this is a system, I know people who watch TBS regularly probably heard about this a ton, so I'm not going to go into like great big deep detail about how it works. But it effectively allows you through YAML to declare a new kind of custom resource, which we call a composite resource, or an XR, because CR was taken. And it allows you to teach Crossplane what to do when it sees one of those through a declarative YAML, similar to the one that we were just looking at when I was sharing my screen. So effectively, the idea here is, as a platform team, instead of saying, I've installed Crossplane and I've installed a provider, all right, developers go hog wild, here is basically the AWS API exposed by Kubernetes. They can rather say, I'll have opinions about how that AWS API is used. I'll lovingly handcraft a template or a composition, and then I'll put my own API in front of that. So I think it's really important that my developers can pick what region their database is in, but I really don't want them to be able to pick what machine type it's in. For budget constraints, everyone uses a particular machine type at my company, and maybe an exception or something to do that. So it really thinks about this separation of concern, like this pattern of use the package manager to install a provider, and then build your own sort of abstractions, your own APIs on top of that. Allows you to really get each team working with the parts that they really care about. App developers care about the things that is relevant to like deploying an app, and the infrastructure team is really sweating the details of that infrastructure. As a final note, you can also use the package manager to install those XRDs and all those sort of composite resources at that sort of abstraction layer, so that you can sort of package them up and share them with other people. You can publish them to a registry sort of thing and be like, hey, here's an example of how I think managing subscription work, and you can now use this. Or you could just use them, if you've got 10 Kubernetes clusters all running Crossplane, you could write the abstractions once and then just use the package manager to install them on all your clusters.
Yeah, there's a lot of things baked into that. One of the things that immediately comes up for me, and for lots of users of Crossplane that I talk to as well, um, we've got strong separation of concern, right, in this model. What does the isolation look like? So those sound kind of similar, right? But more so the tenancy model of how infrastructure is being deployed. So typically Kubernetes users, right, are going to achieve tenancy in one of two ways, or multi-tenancy in one of two ways. They're going to have different clusters for different teams, business units, customers, etc., or they're going to have different namespaces within a cluster, right? Those are kind of the two major units of isolation. Crossplane makes some assumptions about how you're doing multi-tenancy, but it can also be enabled to work in both of those scenarios. What in regards to cluster scoping and namespace scoping? I know when we talk about composition, we kind of like talk about it generically, but there's kind of like the XR and XRC approach, which may be kind of opaque terms to the audience. So if you want to define those, that would be great. But kind of like talking about how you separate what's available to who, whether you do that on a cluster scope in different clusters, or you do that per namespace with the cluster scope maybe managed by an infrastructure team.
Yeah, sure. I'm going to just share my screen again. This is probably a diagram that a lot of people have seen, but just as a bit of a visual guide here. Apologize if I end up looking in the wrong way. I'm using a dual monitor setup where Zoom just like randomly moves where Dan is when I share my screen. So one thing that Bassam, one of the other the founder of Crossplane and Upbound, and one of the steering committee members, really pushed for, and that I think was a really great idea when we were sort of designing this whole composition thing initially, was that it should be possible to build these abstractions with two different audiences in mind. As an SRE, we use different terms for these personas. I tend to think SRE because it's the job that I did for a long time. But you also say platform team member, cluster operator, the person installing Crossplane, so that the people they support who are using their Kubernetes clusters can make use of it. So they might want to build these abstractions for other folks. They might want to build these abstractions for their customers effectively. And really, the quintessential use case we always come up there is say, hey, I want to offer you this nice simple database that you can imagine, nice simple cache, a nice simple queue, or something like that. But they might want to do it for themselves as well. Like that. There is plenty of infrastructure that we effectively could think of as like supporting infrastructure that like really isn't the kind of stuff that the typical app team will be spinning up. So that example I gave before of the database was a little bit contrived, because typically an app team is not going to spin up a VPC for every database that they're probably going to have a VPC that is managed by some simple central infrastructure team. And ideally with Crossplane, we'd love for you to be able to use Crossplane to manage that VPC. But then, one thing we're really fortunate to have is, not only we have basically, a community of people who are out there using Crossplane in anger. We have a community of people who've been doing this kind of platform work for some time, and we've sort of really approached the architecture by rooting it in real use cases that we'd see out there. And one of those use cases that we'd see is, you've got a platform team and they want to spin up a VPC. They want to spin up some, I don't know, maybe firewall rules and subnet groups and things like that. And they want to manage that with Crossplane. But then maybe they want to put that behind a composite resource. But then they also want to, which is our API abstraction of XR. But then they also want to let their customers manage databases, and those databases should go into that VPC. And you want to model all of that in Kubernetes. Now you start to run into some interesting scoping challenges with Kubernetes, by which I mean the namespace versus the cluster scope. So one thing that we did, informed by previous design decisions in Kubernetes to some extent, that helped our model a lot, was we made the novel decision to make most of our infrastructure cluster scoped, so it doesn't live within any namespace. It all sits under the cluster scope. And the idea here is that the folks who are setting up Crossplane and offering Crossplane are the same folks who are running the cluster. So they're the folks who are in charge of like the nodes in the cluster. which are cluster scoped resources. They are in charge of that granular level, like specific. There is an RDS instance, those one-to-one managed resources that map to the Kubernetes API. They can also define composite resources that exist at the cluster scope as well. So they could say, it's a real pain in the behind to have to write all of this YAML over and over again, or apply this big bulk group of YAML over and over again every time I want a VPC and 10 subnets or something like that. So I'm going to write a composite resource that simplifies this. It's very similar to writing a module in Terraform sort of thing. You basically say, here's my inputs, here are the outputs, and go render it out to like this more complicated infrastructure setup. And just for reuse and reshareability, you might want to do that for yourself in the cluster scope. And then you want to be able to say, okay, my users who are definitely working in namespaces. It's a very common pattern that we see for each team to have their own namespace within a cluster sort of thing. Or you can also get like a production namespace or something like that. That's where they're creating their deployments. That's where they're running their apps. It's where they're doing their container orchestration. They want to be able to spin up their databases and their queues and all that kind of good stuff there as well. So the model that we have that enables that is you can optionally, as a platform builder, offer a claim for your composite resources, which is an evolution of the typical persistent volume claim pattern in Kubernetes. So in our case, the claims are basically a fairly well transparent namespace proxy for those cluster scope things. And where this helps is if you have something like a VPC and that's run by your platform team, and then you have 3 different app teams, each with their own namespace, how do you put a database in each of those namespaces and have them reference the same VPC while not violating Kubernetes namespace constraints? So Kubernetes basically says if you're in a namespace, you're allowed to see modular RBAC rules, but at most you can refer to things that are in that namespace, and you can refer to things up in the cluster scope potentially. But you can't jump from one namespace and just make a reference and say, hi, I'm in the food namespace. I'd like to refer to this thing that exists in another namespace, because there's supposed to be isolation there. There's supposed to be sort of firewalled off from each other in the logical sense, not actual firewalls. So what we do there is we say, okay, we'll make all these relationships up at the cluster scope. You can put the VPC in the cluster scope, and there is a resource that represents the RDS instance, let's say, at the cluster scope as well. And you can basically say, hey, RDS instance, go in the VPC name foo. And we'll make that connection up at the cluster scope, but you'll still get a namespace scoped resource to work with as an app team. I'm not sure if I explained that super well. I think if you start to look at how else you could do this, there's only really a handful of ways that it's sort of possible to do this within the constraints of Kubernetes. And one subtlety here is that when we talk about resources referring to each other, we're talking about resources in Kubernetes referring to each other. So keep in mind that a resource in Kubernetes can have a name, and then that name doesn't necessarily have to be the same thing as the unique identifier of the thing in the provider. So often in cloud providers, or in many cases in cloud providers, especially with networking stuff in AWS, you don't get to control what the thing's unique identifier is. You create a VPC, for instance, and AWS says, here's the VPC identifier that I generated for you. It is now this. And you might not want your users to be like, put this in VPC, ABC123. You might want to be like, put it in the, Acme East VPC or something like that. So you want to refer to the Kubernetes, the name that, they can see in the Kubernetes API server, which means you're going to use something called an object reference in Kubernetes that basically says, hey, go refer to a VPC named this effectively. If you want to do that sort of have that level of flexibility where you've got different teams collaborating to plumb their infrastructure to each other, there's only a handful of ways to do it. The naive way, I think, is just you say, well, all infrastructure goes in one namespace. So you have the infrastructure namespace, and then you end up in a kind of a potentially things getting a bit hairy where like many teams are all working in one namespace sort of thing, and they're all creating their RDS instances there, and the platform teams also creating the supporting infrastructure there. We sort of felt like that wasn't likely to shake out that well, to scale out that well. Or you can just eschew Kubernetes resources in certain places and just be like VPCs and whatnot just aren't managed in Kubernetes, which is a little bit of a shame, I think, because that means you're only using Kubernetes for kind of managing half your infrastructure or some of your infrastructure. Or you can say we use Kubernetes for all of the infrastructure, and there's kind of like there's app team namespaces, and then there's the special infrastructure namespace. But the app team databases and whatnot can't go and use the VPC from the infrastructure namespace. They just have to use the cloud identifier. They have to say go be in VPC 123, and by coincidence, that happens to be the one that's managed this namespace, but there's no references inside Kubernetes there. So for a number of reasons, we think that this shakes out pretty well. It's also just nice, if you assume that the platform team is operating the cluster scope, the platform team can just see everything that all their users are doing in the cluster scope. They can see all of the infrastructure in one view, but then people can see their own little team sort of lenses into the infrastructure at the namespace scope to see what they're
doing. Yeah, that was a very good rundown. And I saw in the chat while you were explaining that Rich mentioned. Well, I mean, you gave a pretty good explanation there of namespace versus cluster scope. And Rich mentioned that he sees a lot of folks who want to isolate per cluster, right? And this could be like kind of complicated, right? If you're defining all these different abstractions in a cluster and you want to have a consistent kind of API, I guess, per cluster, that could be sort of hard to replicate in each cluster, potentially kind of tedious. But you mentioned that you can package up these abstractions into a configuration package, right? And so we have the providers, right, that bring the kind of nitty gritty managed resources. And then when you write these XRDs and that sort of thing, you can also put them in a package and you can establish dependencies between them. So this is something that I feel like we hear folks who use Helm or use things to install operators into a cluster, right? That there's no concept of them really depending on each other unless if you're subcharting them. And so you end up with kind of this messy model of different operators who may be overlapping in functionality and that sort of thing. And that's one of the benefits, I think, of having the Crossplane package manager, right? Where it's going to make sure that you don't have two controllers reconciling the same thing. And that sort of thing. I thought it might be useful here. I've installed Crossplane on a local cluster. If we could maybe talk about some of those things that you were just describing and maybe show them with some kube control commands, it might make it a little easier for folks to digest. So
Dan, just now as the designer and author of the Crossplane package manager, are you saying the Crossplane package manager is good software?
I would endorse it for usage, yes. But obviously not near as powerful as composition, which you are the one of the designers of as well. No, so I've got Crossplane installed here, and we can just kind of take a look. I've got a local kind cluster going, so this is kind of something we do almost every show, it feels like. But I feel like you gave really good rationale, but I have trouble at least following like words. And so I like to see things in the cluster and run the commands. So basically all we've done here is installed Crossplane, right? So I'm going to install a configuration package, right? Which Nick said that was something that brings abstractions. And then I added on to that, you can depend from this configuration package on provider packages, which bring the granular resources, right? So if you're going to create a cluster abstraction, they can either create a GKE cluster and EKS cluster. You need those providers present, right, to be able to reconcile those resources. So I'm going to go ahead and install a configuration which has some of those dependencies, and then let's look at all the different types that are then available to be created in our cluster and what scope they're at and that sort of thing. So we have a kube control plugin, and you can just install a configuration. The other thing we should probably note about our packages, right, is that they're just OCI images, which is really convenient when that's kind of like the way that you're installing different things into clusters already, your different workloads. These are also OCI images that you can just build with Docker. We actually have built into our kube control plugin building functionality as well. You can push them to Docker Hub, or in this case, we're pulling from the Upbound registry, which is a Docker distribution. You can put it to Harbor or, AWS container registry or whatever. And then you can just install them. So when you install a configuration, it is going to check and say, does this configuration have any dependencies? And if so, it's going to go ahead and add those providers. And a provider, as we already defined, right, a controller and a group of CRDs. So that's the definition. That's all you can put in it. And so we should see here that we now have provider AWS being installed, as well as provider GCP, which are both dependencies of this platform ref multi-k8s. And then once they become healthy, that our configuration is going to be able to say, oh, okay, all my dependencies are resolved. And, I'm good to go now. And actually, I think if we looked at configuration revision, it's going to tell us a little bit about those dependencies as well. So yeah, you can see here, well, it's kind of poorly formatted, but dep found 4, dep installed 3. I actually don't know what the third dependency is, but we can take a look at that in a moment. But it looks like, it has Helm in Azure as well. All right, so once all those come available, you'll see that the configuration revision's healthy, right? We found all of our dependencies. And then if we look at our packages, we now have everything there. So right off the bat, right, with one command, you could kind of replicate, right, your API that you have in one cluster in another one just by having Crossplane installed. So I think that's kind of nice if you're doing like what Rich said, and you're using cluster isolation rather than namespace isolation.
Yeah, there's definitely interesting architectural decisions you can make there as well. We see some folks saying, maybe each cluster belongs to a team. Each team has their own account, or depending on the account project, whatever cloud you're using, sort of thing. And then they have all of their own infrastructure that lives inside that, or you can have multiple clusters all sort of in one big VPC or something like that, where you do need to maybe start looking into. You need to make sure that someone doesn't just go create an RDS instance called cool instance, and then in another cluster someone creates cool instance, and those two will start to sort of fight with each other. There is some sort of things you need to keep on top of and think through when you're deploying Crossplane.
Yeah, absolutely. And so, right, the CRDs are going to be present. So if we look at our CRDs, we should be able to see that like AWS is here, right? These are all these small managed resources that you really don't want to be worried about, right? You want to create abstractions in front of these. And so what Nick was talking about earlier, right? The XRD, which is the composite resource definition, is the names of abstractions that, eventually render out to these resources. So we should be able to get those as well. And you'll see here we have things like composite clusters, composite networks, EKS, GKE services. What you're seeing here are two kind of important values. Established just means that it's had its CRDs rendered out, right? So when you create an XRD, it actually creates a CRD. And then you can optionally say, I want a namespace scoped flavor of this. So that's what Nick was talking about if you want to offer it at the namespace scope. So this is the actual source code for what we're looking at here. And I believe in the definition, we should see here, that if you specify claim names, it's going to also create a namespace scoped CRD that has the name that you specify here. So now we basically have two CRDs with the exact same schema, one cluster scoped and one namespace scoped. And that's what the offered true means. Basically, you can provision that at the namespace scope.
Worth pointing out as well, one thing we've identified recently is we've started putting together some reference platforms, we call them, like this one, and they're super powerful, but we also realized we went really big. Like a lot of these are just like, we could spin up the same, give you one lens on a Kubernetes cluster and spin it up in every cloud. But then we're hearing folks saying, like, what about my database? Or like, simple things that my apps need. So we're going to start working on those very soon so that you can see examples of this that are, again, I'll say it'll surprise people, like how complicated it can be to just spin up a database. Azure was actually, so this is a good feature of Azure. This is a really good thing with their API. But they were actually a big driving part in coming up with this infrastructure, because we actually realized you effectively could not always declaratively using GitOps create an Azure database, because when you create an Azure SQL server through the Azure API, it does not allow any traffic from anyone. You then need to go and create separate resources to allow it to accept traffic. So you have to say allow traffic from this virtual network, or allow traffic from these subnets, and those are different CRs that you've got to create. So you're actually going to create, I don't know, 3 or 4 CRs or something like that, and maybe a resource group and things like that, just to get a functioning database in Azure. So you can look forward to us having some examples of, like, what the actual sort of total wall of YAML is for a useful database, as well as the neat abstractions you can use Crossplane to build on top of that, to, so you can offer your as an SRE, you can offer your developers like a nice, easy, opinionated interface to managing databases. And just another, while I'm selling Crossplane, the other really nice thing is that these compositions can all be plumbed out. You can have one interface to your databases. You can define what an Acme database is, what fields that has, what spec and status it has, and then you can have different implementations behind the scenes. So if you chose to do one thing today and realized you were missing something or wanted to change it, you could switch that out for a different composition.
Yeah, that's actually, I think what we're seeing here is with our composite clusters here. So these are all abstract types. The composite cluster actually is an abstract type which composes other abstract types, right? So EKS and GKE, if we actually looked at, we could also say get compositions, which are going to show the different like abstractions. And they're very helpfully named here as well. You can see that we have a naming pattern in this case of naming the XRD that the composition matches to. So you can see we have an EKS for composite clusters and a GKE for composite clusters. The way you select one of those right now is by label selectors. There's also some other mechanisms for like enforcing always using one of these compositions and that sort of thing. But yeah, Nick's totally right. As a developer, you could say, give me a cluster with label, like dev, and that could go to EKS, and give me one with prod, which would go to GKE, which that's a very contrived example. I can't really think of an organization that does that, but maybe more appropriately, it would give you like a large RDS instance or a small RDS instance, right? Based on these different labels that the infrastructure team can put on them. And if we actually look at the CRDs that exist, like I said, for an XRD, it either creates one or two CRDs, right? If it's just cluster scoped, then it's going to create just a single cluster scope CRD. If it's also offered or claims are defined for, it's going to create a namespace scope variant as well per the name. And once again, we're following kind of a pattern here. You don't have to follow this, but seems to work well for us, of composite for if there's a cluster and namespace scope. So we should see a CRD for this. And I'll just actually go ahead and list the all the multi-cates ones. And you can see that we have both a composite clusters and a clusters. And if we looked at the scope of those, the cluster is the one you'd create at the namespace scope. Composite cluster is the one you would create at the cluster scope.
Yeah, there's an unfortunate implementation detail here that when you write your XID, you have to tell it what is the kind of the cluster scope one and what is the kind of the namespace scope one, and they can't be the same. So you have to think of some nice way to vary them. You don't have to call the cluster scope one a composite, whatever. You can call it whatever you like, sort of thing. You can call it the ops cluster or something like that. But it's just what we've gone with by convention.
Yeah, I think in one iteration, did we have it where we automatically like appended composite to it or something like that? And in some cases, that's not really appropriate. So
yeah, with V1, you just get to pick. I've taken to calling the cluster scope thing an X cluster because X is our letter that we've attached to the Crossplane.
Yeah, absolutely. Well, I know we're kind of nearing the end of time here. And I think we've gotten a good overview. There's kind of like countless scenarios we could talk about here and how you could enable this. And hopefully we'll actually have some Crossplane users on in future episodes to talk about some of their scenarios that they use this for. If you want to check out our Crossplane Day, Community Day videos from just before the new year, right after Crossplane 1.0 came out, there's some interesting examples in there as well. There's like a playlist on the Crossplane channel. So you can go check that out. But Nick, while we have kind of like 5 minutes left, I just want to give you the floor. And if there's anything else you wanted to mention or anything like, you feel passionate about in the way Crossplane does things or that you think is really useful, I wanted to give you a moment to talk about that.
Yeah, sure. So one thing I'm curious about is I'd love to hear from folks whether this architecture sort of resonates with them. We being informed by our sort of real world use cases and our own backgrounds helps a lot. But I want to make sure that this isn't too imposing. Adding this functionality does increase the learning curve a certain amount compared to just having simple CRs that represent cloud provider APIs in a namespace. We talk with folks working in similar spaces. Like my team has regular calls with folks working on Config Connector and ACK and things like that. And one thing I'm starting to see is that the more mature projects in this area, the ones that have been out there longer, Coffee Connector, I think, is one of the longest standing ones apart from Crossplane. And they're starting to see that people want these abstractions and things like that. They're starting to look at ways to address that as well. I think Crossplane is really sort of taking the best approach there, in my opinion, because we do all of this behind the API line. We don't just say, hey, render a Helm template to create all of these things. Like we actually give you a Kubernetes API that you could then go and call from Terraform or curl or Argo or something like that. We give you an API concept there, the claim or the XR. So I think we're on the right approach here. But I'm really curious to hear from folks. Is this just too complicated? Do you just want namespace scoped resources sort of thing that just directly represent the cloud, and that's enough for you? And especially if I'm very curious to hear whether folks are successful with that pattern. Like folks who by which I mean, is there people out there who are using something like that and they've been using it for 6 months or a year and it's working really well? Or conversely, have people started running into some of these issues that we ran into ourselves when we were designing the system? So my username on most things is negz. Slack.crossplane.io is a great place to find me. You're more than welcome to DM me and give me sort of candid feedback as sort of the engineering and architecture lead on this from Upbound's end. I would really love to hear from you all.
Yeah, absolutely. I totally agree. And just kind of adding on to that, I guess, for folks that feel like it is really complex, definitely one of the things that we're looking at now that we kind of have like these APIs established, right? And we have a 1.0 that we can say these are stable versions. In fact, the other day we just kind of released our support schedule for how things are going to be supported over time as well. We can invest a little bit more in user friendly kind of tooling and that sort of thing. So if there are things that you look at Crossplane, you're like, wow, there's a lot going on there. I really don't even know how to start. If there's tooling that you can think of that would make that process easier for you. One of the things that we've talked about is, I installed that multi-K8s platform ref, and Nic kind of made the accurate assertion there that was kind of a complex thing that was going on. It's like, oh, whoa, okay, like we're spinning up all these things on GKE or on EKS. Maybe we can come up with some like more friendly starter packs and that sort of thing to help folks, install it and say, oh, okay, like I know what creating a bucket means, and kind of like grow through it. So if you have ideas on that, we definitely welcome those as well.
Yeah.
Well,
Thanks
yeah.
for having me on, Ben.
Yeah, absolutely. It was great to have you. And for all the listeners, I definitely appreciate Rich with the great commentary in the chat, as well as everyone else who tuned in. As Nic said, you can always find us in slack.crossplane.io. We are very responsive. I think we pride ourselves on that a little bit. And we'd love to chat with you more. And with that, we'll see you in 2 weeks.